Okay, this is the P3 paper from January 2023. It's question number 4, and the first part here is algebraic methods. We're going to be having an improper fraction here that we're going to have to divide, and then the second part is integration. We'll look at that when we get that far. So part A says we've got that quartic divided by x plus 3 all squared. So when we're going to do that, we're going to write that as an algebraic long division, but just first of all work out what x plus 3 all squared is. That's x squared plus 6x plus 9. So it's going to be our function there. Be really careful copying this down. 2x to the 4, 15x cubed, 35x squared, 21x minus 4, that's all divided by x squared plus 6x plus 9. So let's have a look at trying to do that then. So a quick reminder of algebraic long division. We say how many times does x squared go into 2x to the 4? That's my first thing to check. It goes in 2x squared times, and then it's this multiplied by everything there, which is going to give me 2x to the 4, that's the whole point, that must be exactly the same, plus 12x cubed and plus 18x squared, and then I'm going to subtract that away. So as I said, these need to be the same as each other, so they cancel, and then what do we get left with? Well, 15 take away 12 is 3x cubed, 35 and 18 is going to give me 17x squared when we subtract them. And then when I've got that far, just bring down the 21x, bring down the minus 4, and now I just simply repeat that process. This time, how many times does x squared go into 3x cubed? Well, it goes in 3x times. Now what we should find here is that these are getting one smaller each time in terms of the powers, or at least getting smaller. So 3x multiplied now by x squared plus 6x plus 9, I'm just repeating the process, is going to give me 3x cubed, they're going to cancel in a minute, plus 18x squared, plus 27x, and then just like last time, I'm going to take them away from each other. They will cancel. Be careful here, 17 take away 18 is going to give me minus x squared, 21 take away 27, we're going to get minus 6x, minus 4, and then the last part, how many times does x squared go into minus x squared? Well, it goes in minus 1 times, so minus 1 all multiplied by this is going to give me, right, so it's minus x squared, minus 6x, minus 9, and we knew it wasn't going to be a factor. We knew it wasn't going to have a 0 remainder when I do that. Just be careful with this last step. First two are okay, but minus 4 minus minus 9 is minus 4 plus 9 is going to give me a remainder of 5. Now, we want to write it in this sort of format up here. If ever you get a little bit confused by this, just in your head, don't write this down, but do something like, I don't know, 24 divided by 5. When you did 24 divided by 5, when you go through the process, it would be 4, and then 4 would be left over as the remainder here. What does that turn into? Well, it turns into 4 and then 4/5, doesn't it? Okay, this bit is a remainder, is written down as a fraction with 4 the numerator and 5 the denominator. So now that I've got that, I can almost do the same thing here and say, okay, my function then is going to be the multiplier, the correct name for it, the quotient. The multiplier there is going to be 2x squared plus 3x minus 1, and this is a remainder, so plus 5, but we don't just write down 5, do we? We wrote down 4/5 there, so we're going to write down 4 over, well, you could start off with x squared plus 6x plus 9, but actually that wasn't given to us in the question, so I'm not going to leave it like that in the question. It was x plus 3 all squared, so that's how I'm going to have my part written down when I'm doing that. Okay, so if we look then and compare that to the answer, yeah, it's in exactly the format that we wanted there, so we can work out what A, B, C, and D are. Part B then says, can we integrate fx, which means, yeah, can we integrate this function? The 2x squared plus 3x minus 1, they're no problem, but it's just looking at this one here, 5x plus 3 squared, or 5 over x plus 3 squared. But this isn't that much of a problem because when we're looking at this, first of all, I can call it 2x squared plus 3x minus 1 plus 5x plus 3 to the minus 2 dx. And then we can do this one by inspection. What we can do is, because the differential of x is just 1 in there, this is actually a relatively simple one. If you want to, you can try it. So you can say, well, I think that the integral is 5x plus 3 to the minus 1. Let's differentiate that. If I differentiated that, I'd get minus 5x plus 3 to the minus 2, multiplied by the differential, but multiplied by 1 there, which means, yeah, we pretty much, well, we know the integral of that is equal to that, so we've just got the minus that we need to take care of in here. If you're not sure about that, go and have a look at some of my other videos on integration in particular. I'm going to get rid of that bit here, just in terms of for the length of this video then. If we're integrating it, just integrate each term separately. So add 1 onto the power, divide by the new power. Add 1 onto the power, divide by the new power. Obviously 1 just becomes x, and then this one here becomes minus 5x plus 3 to the minus 1. Don't forget your constant of integration. Okay, so at this stage, just when you finish it, just go back and check. So we've got 3 marks, but make sure we're not losing any marks for accuracy there. Okay, hopefully that all makes sense.